Hello viewers, this is Prof 1 Tutorials. My name is Alfred Amprofi, and today we are going to look at sample questions under Cube and Cuboid. Sample questions under Cube and Cuboid. So let's look at some few questions and how we are going to play around those questions. So viewers, let's get started. The first question is, question 1, a fuel storage tank in the form of a cube the total surface area is 201.84 meters squared. Full stop. Calculate the volume of fuel that can fill the tank correct to the nearest hundredth. So viewers, this will be our first question under cube. So the question is a fuel storage tank in the form of a cube. So because the storage tank is in the form of a cube, then let's get the sketch of a cube. All right, so this is a cube, and the question said the total surface area is 201.84 meter squared. So total surface area has been given to be 201.84 meters squared. 84 meters squared. Now, we know that the total surface area of a cube is giving us 6L squared. This is the total surface area of a cube because a cube has 6 faces and the area for each face is L squared. In that case, the total surface area will be 6 multiplying the L squared. So we can equate this to 201.84. Now, because this is the formula for the total surface area and this is the value for the total surface area, then we can equate the two. Now from here, we need to make L squared the subject. So I will divide here by 6 and divide here by 6. This can cancel this. In that case, we have 201.84 dividing 6, and we are going to have 33.64. 33.64. Now from here, we need to get L. So you take square root on both sides. So taking square root on both sides, then square root of 33.64 we have 5.8 meters. Meters because the total surface area was in meters squared. So this will be the length of the cube. Now the question said we should calculate the volume that can fill the tank. So we need to calculate the volume of a cube. So if you want to find the volume for any prism, it's always equal to area of its base times the height. Now this side is L, this side is L, the height is also L. So volume of fuel that can fill the tank is going to be area of the base multiplying its height. Now from here, because the base is in a form of a square, then L times L is going to be the formula. Then every cube has all its side to be L. In that case, even the height is also in a form of L. So the height is also L. Now we have the L to be 5.8 meters. So we have 5.8 times 5.8 times 5.8. So when you multiply 5.8 times 5.8 times 5.8, we have 195.112. 112 meters cube. It's meters cube because this is meters, this is also in meters, this is also in meters. So m times m is m squared times another m, we have m cube. That is why volume of any figure is always measured in cubic units, depending on the unit. If it is in meters, then meter cube. If it is in centimeters, we have centimeters cube, and so on and so forth. Now, the question said we should correct to the nearest hundredth. Now, to the nearest tenth is the same as 1 decimal place. The nearest hundredth is also the same as 2 decimal place. Now we have the nearest thousandth, and basically it is also to 3 decimal places. So we have 3 decimal places. All right. So because it's to the nearest hundredth, then we are to correct this to 2 decimal places. So we have 1, 2. Now when you get to the second value, the number that follows is less than 5. In that case, we have the answer to be 195.11 meter cube. Into brackets, the nearest hundredth. So viewers, anytime a question is given and they ask you to correct to the nearest tenth, it means 1 decimal place, to the nearest hundredth, 2 decimal places, to the nearest thousandth, that is 3 decimal places. So you can bear that one in mind. Now let's look at the second example. Example 2. The figure below is an open rectangular box. 3 centimeters long, 4 centimeters wide, and 5 centimeters high. Find the A, total surface area, B, volume, C, diagonal, HB, D, angle, diagonal, mix with the base. So viewers, this is the second example. So if you check the figure, this is the figure we are asked to find the total surface area, then the volume of this rectangular box, as well as the diagonal HB, then the angle, this diagonal mixed with the base. So that is basically what we are going to find. So now we are going to look at the total surface area. Now with the total surface area, because it's an open rectangular box, it means that the top is off. So this looks like the small box we have within a matches. So the front is available, its back is available, this side is available, this side is also available, then the base is also available. It's only the top that is off. In that case, we are going to have 2 multiplying. Don't forget that this is the length, this is the breadth, and this is the height. And each dimension was given. So we have 3, we have 4, we have 5. So because the front and the back is available, then it's going to be length and the height. So we have L times H. And you're going to multiply it by 2. Then again, this side and this side is also available. So we have 2 multiplying the breadth times the height, plus then the base is available. So it's only the base that you are going to add to it. So we have length times the breadth. Now in view of that, we have the length to be 3 centimeters because it's 3 centimeters long. So we have 3 times and 5 centimeters high. So that is the height, plus 2 multiplying the breadth is the same as the width. So we have 4 times 5, which is the height. Then the length is still 3 times the breadth is also 4. So we will just make substitution of the dimension. So from here we are going to evaluate. So we have 2 multiplying 15 plus 2 multiplying 20 plus 12. 2 times 15 we have 30 plus 2 times 20 we have 40 plus 12. And when you had 30 plus 40 plus 12, we have 82 centimeters squared. Centimeters squared because we are looking for the total surface area. From here, we are going to look at the volume. So let's look at the volume. Now, basically, with a volume of any prism is always equal to area of the base. So we have area of the base multiplying the height. Multiplying the height. That is why volume of a cuboid or any rectangular tank, box, or rectangular prism is L times B times H, because the L times B is the area of its base, L times B. Then the height is H. Now we have the length to be 3. So we have 3 centimeters times the breadth, which is the same as the width, 4 centimeters. Then we have the height to be 5 centimeters. And 3 times 4 times 5, we have 60 centimeters cubed. 60 centimeters cubed. So centimeters times centimeters is centimeters squared times another centimeters, we have centimeters cubed. And that is the volume of the rectangular box. So we are still going to look at the C part of the question. So the C part is the diagonal HB. The diagonal HB. Now when you check the diagonal HB, before we can get that diagonal, we need to get the distance DB. But DB is taken from the rectangular base, which looks like this. So we have A, B, C, D. Now, if we are able to get DB, we can easily get the HB. Now, the DB is a rectangular surface. In that case, it looks like this. So now we have A, B, C, D. And we still have DB drawn like this, for which we can get a right-angled triangle. AD is the breadth, for which is the same as the width, which is 4 centimeters. AB is the length, which is also 3 centimeters. So from here, if we want to find DB, then we have to use the Pythagoras theorem. With the Pythagoras theorem, we are going to square the hypotenuse. And viewers, where the 90 degrees faces is always the hypotenuse. So the 90 degrees is facing the short dashes. That is why that side is the hypotenuse. So we have dB squared is equal to 4 squared plus 3 squared. We still have dB squared, which is equal to 16 plus 9. Then dB squared, we have 25. Now, if we want to find dB, so dB is going to be square root of 25. Then dB is equal to 5 centimeters. So the distance dB is 5 centimeters. Since we have dB to be 5 centimeters and we have HD to be the height, now HD is the same as FB and is the same as EC, and they are all height. We have the height to be 5. So from here we are going to pick this triangle, for which is also a right angled triangle. So we are going to use this right angled triangle to find the side HB. So viewers, let's move on. So from that right angled triangle we have HDB. HDB. Now we know that HD is the height, which is 5. We have DB is also 5 centimeters. Then now we can easily get the distance HB, for which HB is also the hypotenuse, because the 90 degrees is facing the HB. So we have HB squared is equal to 5 squared plus another 5 squared. HB squared is equal to, we know that 5 squared is 25 plus another 5 squared, which is also 25. So we have HB squared to be 50. Then from here we are going to take square root on both sides. So square root here, another square root here. This will take off this. Then my HB is going to be 5 root 2 centimeters. So viewers, this will be the HB, which is 5 root 2 centimeters. And that's the diagonal HB. So therefore, the diagonal HB is 5 root 2 centimeters. So we can conclude so that your solution will be fantastic. Now viewers, we are going to look at the last sub question under this particular question, which is the angle that the diagonal makes with the base. And from the sketch they have indicated theta. So this theta, we are going to get it from this particular diagram, and that is HDB. So we are going to take that angle from the same sketch. So viewers, I'm going to use this same diagram to look at the angle this diagonal HB makes with the base from here. Now in that case, we know that this side is opposite of the angle. So this is opposite. This side is the adjacent. Then this side, we know that is the hypotenuse. The hypotenuse. Now viewers, when we have opposite, adjacent and hypotenuse, then it will take us to trigonometry. So from this question, we can use any of the trigonometric ratios. In that case, I am going to select tan because I know that this is opposite, this is adjacent, and tan takes opposite and adjacent. So we have tan theta to be equal to opposite over the adjacent. I still have tan theta to be equal to, my opposite is 5. Then I have adjacent to be 5. So theta is going to be tan inverse of 5 over 5. Then here, tan inverse of 5 over 5, we have our answer to be 45 degrees. So from here we can just conclude that therefore the angle, the diagonal mix with the base is 45 degrees, and that will be your conclusion. So viewers, we are going to end the question here. In the next video, we are going to look at the triangular prism. Triangular prism, some of the example of a triangular prism is the wooden figure they use it to chalk the big trucks, for which we sometimes call it the car chalk. That is an example of the triangular prism. So in our next video, we are going to look at how we find the total surface area, how we find the volume, and some questions related to the triangular prism. This is Prof 1 Tutorials. Keep on watching. Don't forget to subscribe if you haven't subscribed yet. Stay tuned. Bye bye.